Obesity is defined as an excess of body fat resulting in a body mass index above the normal range. Worldwide obesity has almost tripled since 1975. The World Obesity Federation estimates that by 2030, 1.56 billion people over the age of 5 will be living with obesity globally. In the US, 19 states had adult obesity rates at or above 35% in 2021, more than doubling since 2018. Small bowel microbiome is a contributing factor to obesity prevalence, but it's just one piece of a larger puzzle. Stool studies indicate that gut microbial populations are altered in overweight and obesity. However, there's limited knowledge about how the small bowel microbiome changes with increasing BMI. In this study, we explore how the small bowel microbiome differs in overweight and obesity versus normal weight, using subjects from the Reimagine study at Cedars-Sinai. 3 subject groups are defined: normal, overweight, and obesity. This is the first and largest study to examine the small bowel microbiome as it relates to overweight and obesity compared to normal weight. From the 3 subject groups, we find 4 different patterns of duodenal microbial profiles. These patterns show the relationship between the small bowel microbiome and BMI. These are the patterns we identified. Overweight specific, microbial changes differed between normal weight and overweight, but not between overweight and obesity. Obesity specific, where microbial changes differed between obesity compared to both normal weight and overweight. Escalation, where the direction of microbial change persists throughout the spectrum of normal weight to overweight to obesity. And de-escalation, where the direction of microbial change from normal weight to overweight reverses from overweight to obesity. These are the microbiome changes we observed in each of the 4 profiles. Differences in the RA of the most widespread duodenal genera included changes that were specific to each profile. Although most findings are unique to the small bowel, genera like Bifidobacterium and Lactobacillus, previously linked to obesity in stool studies, were also identified. The following changes were identified in specific microbial metabolic pathways and related parameters. These findings illustrate that while stool studies have provided valuable data, direct analysis of the small bowel has yielded specific targets for further study. Our next steps are to explore these changes in an animal model with the goal of developing potential therapies.